Welcome to Convergence. My name's Michael Dorn. I'm a California attorney. I don't have a dog in the hunt. Albert Einstein once stated that among the most difficult problems in all of physics is the Earth's magnetic field. I argue that the Earth's magnetic field is among the most difficult problems in all of biology. Over the years, I have been on many debate bulletin boards and seen many politicized views about carbon dioxide as a greenhouse gas. I'm neither a warmer nor a so-called skeptic. One example of this is a website called CO2 Collation, co2collation.org. And when they see something that doesn't rhyme with the greenhouse gas theory, then they will be all over it. And as you know from previous videos, I believe CO2 is significant forcing, but it's an electrical forcing. It has to do with freeze rates in clouds that are supercooled. It helps the clouds organize and trap heat in the context of electrical fields. The best example is the fire that caused me to evacuate my home in 2018, the so-called car fire, where you had 143 measured on Doppler firenado. You're talking about carbonated clouds at 40 or 50,000 feet. That's what smoke is. It's water and carbonation. And it's supercool cloud droplets, and as they're turning to ice, the electrical fields involved, there was particular space weather at that time. You get a very conducive condition for a fire, and then the clouds organize underneath the fire becomes sucked up by a tornado underneath it. And that's just one example of many. So what is being observed here, and the CO2 Coalition was pointing out, is that, and I'm quoting from their article, it has nothing to do with CO2. I would say it has nothing to do with CO2 as a greenhouse gas. It has everything to do with CO2 in clouds. So what they're talking about is a study that that was published in Earth and Space Science by Robert Lemon and et al. In 2021. The new study ties solar variability to the onset of decadal La Nina events. So I should point out a couple things. There's a solar cycle which has been observed since 1700 or whatever, maybe even a little before. And it's this idea that there's sunspots, higher numbers, then it lowers and that's like an 10 and a half, 11 year cycle. This cycle that they're talking about is 22 years. And that's because this solar cycle that we have right now has the opposite pole of the previous one. And so you're getting a back and forth pole change with each solar cycle. So when you account for the magnetic orientation of the solar cycle, as you go from one to the next, then that's a different cycle. And even though it's producing the same things. But what's unique about the solar cycles, if you have the polarity of one, it's also affecting another particle. That's cosmic rays. And you go to spaceweather and other spaceweather.com and other sites that are monitoring now cosmic rays, you'll see that during the minimum of the solar cycle, you're seeing higher cosmic rays. And basically cosmic rays are protons. And so what you're seeing then is in that context of what the orientation of the sun's magnetic field, not just the sunspot cycle, but what the orientation of that magnetic orientation is, that that there's a match up between an orientation and then the higher level of cosmic rays. So I would say that this ties it in neatly with CO2. And it's another implausible complexity, as again I've talked about before, that the Earth's magnetic field and its reaction to space weather inputs becomes oriented, or has become over time, the biosphere has honed it to become oriented with what the inputs of the solar cycle are. So I would say different mechanism. CO2 is absolutely part of this dampening that is occurring. Okay, so let's talk about Utah. Just looking at what the levels of the Great Salt Lake were over time, not just recently when it set this record for record low. And to me, this Great Salt Lake is fascinating because it's almost like it's like an isolated dampening system, ecological system within the whole of the system, that we can look at it and kind of see some things. And just like when it was previously at its lowest point, we are also in the same part of this solar cycle where there's a La Nina. So we're in the same type of part of the cycle. But I think that there's some other things going on that affects carbonation. So if we talk about, for instance, if we talk about the car fire and the fact that there was a firenado and you have carbonated conditions, and then space conditions were optimal for a fire like that. And there was other electrical things going on too, but space weather was optimal. And so you get a fire that's producing carbonation, you have electrical conditions just right, and you get a firenado. Well, there are other things that can affect there are a number of things that can affect what carbonation is, and a number of things that can affect what the electrical conditions are to whether it's going to affect the clouds. So for instance, if you have a storm in the Tornado Valley, you're going to have decarbonation from the Gulf of Mexico, and you're going to have frontal activity, and you're going to have a tremendous amount of lightning. So right at the location of the tornado, you're going to have optimal conditions for the phase change from water to ice up at elevations that's going to create this vacuum effect, right? So one of the things that we can do to talk about what was going on what's going on in Salt Lake right now is to just look at the different time periods where it's been doing different things, and then comment on the electrical conditions and what would cause those different things. In 1999, everybody I think is aware of the F5 tornado in Moore, Oklahoma, and that was earlier in the spring. But few people really appreciate that there was a F2 tornado in Salt Lake City in August of 1999. So what's going on there that, again, looking at it from an electrical standpoint, at that point in 1999, the Great Salt Lake was nowhere near the minimum it is now. And at the same time, we were coming out of a 500-year El Nino, and again, we had this 22-year cycle that we're talking about. So we're coming out of an El Nino, going into a La Nina. It kind of reminds me of, like any dampened system, if I'm really hot and I'm sweating like a pig, and then I go into an air-conditioned room, it's like, whoa, it double hits you because your body's feedback systems have adjusted and acclimated to the warmer temperature and started providing a feedback, sweating. And then when you go into the colder room, now the input is totally different, and your body now has to adjust, and maybe you start to shiver a little bit to warm yourself up. So this is kind of like what we're talking about here. When you have a dampened system, it's exactly how the Earth orients itself to what's going on with the sun and the solar cycles. And so in 1999, we had La Nina, and I've talked about this before, where La Nina is colder oceans in the tropical Pacific, and so warmer oceans hold less carbonation. Think warm flat beer. Colder oceans hold more carbonation, and this is 1999 was after Hoover Dam, but it was also after there was widespread use of fertilizers, which would carbonate a lake like the Great Salt Lake. And then, so you had La Nina itself is providing carbonation. You had the fertilizers being used and used in irrigation, and that flow is going into the Gulf of California. And so earlier in the spring, the subtropical jet with highly carbonated water from more fertilizers being used moved towards more. More itself is a source of, Oklahoma City is a source of carbonation, and Salt Lake City itself, cars running, heaters going, or air conditioners, fossil fuel plants running electric grid. You had you had all these different conditions that added to greater carbonation in the context of a La Nina having more or less more lightning, even though Utah is just not known for having tornadoes. And there you have this tornado that is absolutely an electrical and a carbonated event in Salt Lake City. And this is also at the same time that the lake itself had gone from a peak of water. So you have the biological reaction to what's been flowing into the Great Salt Lake, and particularly, I believe, fertilizers were starting to become in play there, as agriculture was starting to become predominant in that area. Alfalfa, number of crops, all irrigated crops, the flow comes off them, goes to the Salt Lake, and affects the amount of carbonation that can get into the air with the surface low. Okay, so if that's the case, what about the opposite? What's going on now with the Great Salt Lake? Well, there's a number of dams that have been built and reservoirs to deal with the growing population. The lake itself starts to adjust to the inputs, and then in the west in particular, the Rio Grande de Santiago, another river that empties into the Gulf of California, began to shift this time of the year that carbonation would flow into the Gulf of California and provide a carbonated feedback precisely during the monsoons when this tornado occurred, and now when this record low has occurred. We're also in this context of strong La Nina, and also we're also in the context of high cosmic rays that have been going for 2, 3, 4 years now, which affects just the electrical ability for precipitation to occur in this area where the Salt Lake drains. And finally, the dams on the Rio Grande de Santiago, they really reduce the methane hydrates because they're going to reduce sedimentation. The rivers go from maybe muddy rivers, or the Santiago goes from a muddy river where in the mountains you get these high flows that carve sediment out, and then it goes to these reservoirs where there's releases of cold water at the bottom of the dams that the biosphere interprets as snow in the mountains, and the feedback is heat. And you're having some of the same things going on with the dams in the Great Salt Lake, where that itself is an ecosystem that is responsive and sensitive to the inflows. And if all of a sudden the inflows have different type of nutrient profile and are colder, released through the dams, the feedback is going to be heat. That's why it started out as a glacial lake to begin with, and the worst thing that life can deal with is a snowball Earth, and so it's learned in these saltwater basins to feed back heat electrically with the decarbonation events if there's flow during the dry season. That's essentially what's going on up and down the West Coast, where the rivers are not drying up during the dry season. They're releasing. Lake Mead is releasing. Lake Powell is releasing. It's not only releasing, but it's cold water. You see sports fishermen catching lunker trout at the bottom of the dams. And that is always interpreted by the nearshore ocean as glaciers. That's what glaciers do. But dams deceive the nearshore ocean and then provide carbonation conditions, methane hydrate conditions, carbonation in the Gulf of California, where there's heat fed back to the system, and it starts fires, it melts glaciers. It's very effective, but that's not what the actual truth of the condition is. It's a biological feedback, and it's been designed to modulate or dampen the Earth's magnetic field. If the magnetic field is too strong, it's going to capture too much gases and water from space, and you're going to have a hothouse. If there's not enough magnetic field, then you're going to get Mars. And life from the very beginning of its existence has had to dampen this, and that's how it's done it. It's provided these feedbacks. So the other thing going on here is I look at the lake elevations over time is Hoover Dam and Lake Powell, as I've been talking about how they're part of the problem and what happened in the 30s. In the 30s, you had the same thing where you had high cosmic rays, and then in the context of disrupting by constructing this dam and filling this dam lake, Lake Powell, Lake Mead, you're going to get these disruptions in methane hydrates. And so if you actually look during the 1930s, you see almost immediately this very heavy trend dropping the levels of the Great Salt Lake, so that in looks like about 1940, there's another low, again corresponding with the reversal of the solar cycle that we're talking about, and so you have 1 in 60 and 1 in 40, and that's where the two low levels of this lake are. It's a time when there's high cosmic rays, and basically the electrical input is such that it's not allowing for rain to occur. So this is this is related to carbonation, sensitive to dams in the whole region, sensitive to fertilizers that we're using in our agriculture, sensitive to the sun, but it's a dampened system. CO2 is highly involved. CO2 is one of the main aspects going on here. I would also point out that the peak of the lake levels looks like about the time that Pinatubo blew. So you're talking about a period of time when you have, and it looks like it also is sensitive to when Mount St. Helens blew, as I'm looking at these lake levels. And that's going to put sulfur ions in the atmosphere, and it's going to cool the atmosphere a little bit, but it itself is an electrical input, very much like carbon dioxide. It affects the freeze rates. The sulfur in the supercooled water droplets is going to cause, in the context of electrical fields, it's going to cause this elongation of and different shape of cloud crystals in the context of electrical fields, how they freeze, and therefore the rate at which they freeze to produce cloud organizations to help storm stack and vent. And so that's what occurred with the Great Salt Lake. You had weather related to what was in the atmosphere. And now with growing carbon dioxide, the problem is a signal noise problem where, yes, it's true that we're talking about decarbonation and carbonation directly into clouds from surface lows, getting into clouds from fires, where the carbonation gets into clouds and then it has an organizational effect. But if you're talking about fossil fuels, then you're talking about the ambient air having carbonation, and then the signal having a hard time getting through. So for instance, with chemtrails and contrails, the jets, it's not something the government is adding to the mix of the jet fuel. It has to do with carbonated water in the context of electrical fields. But that carbonated water is not from any particular signal. Just like fertilizer isn't from lightning where nitrogen is fixed, where you get this connection to the Earth's magnetic field, it's just connected to where the farming is and where the farmers are putting nitrogen in their fields. So you're divorcing it from the dampening effect that it's supposed to have on Earth's magnetic field. Okay, so I'm kind of all over the map a little bit with this, but I hope that gives an understanding of what the context is. It just has to, this understanding is difficult, but it has to come because the discussion of spending millions, hundreds of millions of dollars, say desalinating, or not even desalinating, pumping water from the ocean to the Great Salt Lake. There's talk of more dams, which is part of the problem. And then there's populations moving into these areas where you don't have the water to support the people living there or the agriculture, and it's getting worse because of all these issues that we're talking about. Okay. Good luck. Please, if you like, click like. Please subscribe if you'd like to subscribe. Thank you.